Okay, so let's write the Lewis structures for some of these compounds on this page. So NF3, nitrogen trifluoride. So how do you know what is the central atom? Usually the first element is the central atom. The other way to figure out the central atom is by looking at the periodic table. Whatever is on the left hand side on the periodic table, that is your central atom. So between N and F, N is on the left hand side of F. So there are very few exceptions to this case, but otherwise for most part this is how it's going to work. So you know that nitrogen is going to be in the middle. And then you have 3 fluorine. So the best way to draw out any Lewis structure is to spread everything out as evenly as possible. So fluorine, fluorine, and then fluorine. So then you fill out all the electrons that each of these elements is going to have. So nitrogen has 5 electrons, and how do I know this? Because it's in group number 5. So it has 5 valence electrons. So 1, 2, 3, 4, 5. Okay, 5 electrons for nitrogen. And how many valence electrons on fluorine? Yes, 7. Okay, because it's in group number 7. So 1, 2, 3, 4, 5, 6, 7. I'm writing it in a particular order just because I kind of know what I'm doing, but otherwise you can write it in whichever order you want. It doesn't matter. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It doesn't matter what you do. Okay. All right. Remember, the goal in any compound formation is the octet rule, which means that each element should have an octet number of electron, which is 8 electrons in the valence shell. That's the only way it can be happy. So nitrogen, which has 5 electrons, needs 3 electrons. Fluorine, which has 7 electrons, needs 1 electron. Okay. And so fluorine will go ahead and share 1 electron with nitrogen, and fluorine here can share 1 electron with nitrogen, and fluorine on the left hand side can also share 1 electron with nitrogen. So each of the fluorine now is sharing 1 electron each from nitrogen, which means fluorine, all of these fluorines now are happy because they have 8 electrons. Nitrogen is also happy because it's sharing 3 electrons with fluorine. So at any given time, if you count the total number of electrons on nitrogen, is going to be 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there are 8 electrons on nitrogen. So this is not the final structure. We're going to write the final structure now so that it's a lot clearer for us. So nitrogen in the middle, fluorine everywhere, and one of the shorthands of drawing Lewis structure is representing each pair of electron by a line. Okay, so that's what you do. And so we can represent each pair of electron with a line like this. And then you have these electrons that are being shared between nitrogen and fluorine. And then you also have electrons left over on nitrogen. So on fluorine, there were 6 electrons left over. On nitrogen, there were 2 electrons that were left over. Okay, and this is explained in the PowerPoint also. But the electrons that are bonded between nitrogen and fluorine are called bonded electrons, and the ones that are not bonded, they're called the non-bonding electrons. Okay, they're also called a lone pair of electrons. So for example, here you have 3 lone pairs, which means a total of 6 electrons. Okay, because each pair of electron here represents 2 electrons. So you have 3 lone pairs here, 3 here, 3 here, and 1 over here. Okay, so the total lone pairs on this compound is going to be, yes, 3 and 3 and 3, 9. So that is 10 pairs of electrons, which means really 20 electrons, okay, are non-bonding electrons, and only 6 electrons are the bonding electrons. And that's a very typical question that you get asked. Okay, let's do HCN. So here, because we have 3 atoms, we have to decide what to put in the middle. And usually when you will get Lewis structures like this, you should not have to think too hard. Just go ahead and draw everything out as a line. Okay, especially if there are only 3 atoms in there, then you don't try to move anything. So for example, you don't write something like H and C. Don't move anything, just leave it as it is, because that is how it was meant to be. Okay, so HCN, just leave it like that. Now draw the electrons out for each of these. So hydrogen has 1 electron, carbon has 4 electrons, nitrogen has 5 electrons. And again, I'm getting this from Yes, the periodic table, the group number. Hydrogen is group number 1, 1 valence electron and 4, and then 5 from the group number. Okay, so hydrogen needs 1 electron more in order to be happy. Hydrogen is the one that follows what we call the duet rule. So here is the duet rule for hydrogen. Only 2 electrons in the valence shell. It can't have 8. So here is the sharing between carbon and hydrogen. Now carbon now has 5 electrons. 1, 2, 3, 4, 5 electrons. So which means that it still needs 3 more electrons. So now it's going to share 3 electrons with nitrogen. There. Okay, so it's sharing 3 electrons, which means that what you have now is going to look something like this, where you have 1 bond between carbon and hydrogen, 3 bonds between carbon and nitrogen, and you also have the 1 pair of electron that is left. You can write the electron pair on the left or the right or the bottom, it doesn't matter, it's up to you. I prefer usually on the top so that I know where to look for my electrons, but you can also write it easily. Nobody writes it at the bottom usually. Okay, so do we have any lone pair electrons left on hydrogen? None. Do we have any lone pairs left on carbon? No, not at all. Everything is bonded, and nitrogen has 1 lone pair of electrons left. This is called a triple bond, okay, because you're sharing 3 pairs of electrons, okay, right there. So that is a triple bond, and the 3 pairs of electrons are between 2 atoms, okay. It's not between 3 different atoms, okay. That would be 3 bonds then, but this is a 3 bond because this is a triple bond because it's being shared only between 2 atoms. So that's how we draw the Lewis structure for HCN. This is it, okay. There's nothing much more to it. All right, so let's look at this molecule now. In this case, we actually have a lot many more atoms. So to look at how to do this one, okay, you have to look at how many hydrogens you have. And why are we looking at hydrogens? I am looking at hydrogens first because I know my hydrogens can never be in the middle. They have to be terminal. Why do they have to be terminal? They have to be terminal because they can form only 1 bond. So if they can form only 1 bond, then they can't be in the middle. In the middle meaning that you have 2 bonds or 3 bonds, which is not possible for hydrogen. It's the same thing for halogens. Halogens means group number 7. So those can have only 1 bond. So it has to be terminal, which means that hydrogen is not going to be my central atom anywhere. So which means I have to put carbon and I have to put oxygen as my central atoms. And since I have these 3 hydrogens connected to this carbon, I will put my 3 hydrogens around the carbon, and for oxygen I have 1 hydrogen connected there, so I will go ahead and put 1 hydrogen over here. Okay, so this is what my representation looks like at this point. And now I'm going to go ahead and put in all my electrons. Okay, so hydrogen again has 1 electron each. That's done. Carbon has 4 electrons, so I'm going to go ahead and put the 4 electrons there. And oxygen is in group number 6, so it has 6 electrons. 1, 2, 3, 4, 5, and 6 electrons. So eventually you'll do this very fast and you won't have to do this whole circling thing that I'm doing, but this is good to at least show you for teaching purpose. Okay, so hydrogen needs 1 electron, so it shares 1 with carbon. It shares here 1 with carbon, here also it shares 1 with carbon. That is how the 3 electrons are, the 3 hydrogens are bonded with carbon. Carbon still needs 1 more electron. It has 1, 2, 3, 4, 5, 6, 7. So then it shares 1 electron with oxygen. That makes carbon happy. It's got the 8 electrons. Now oxygen needs 8 electrons as well. So oxygen has 1, 2, 3, 4, 5, 6, 7. Okay, so there we go. We share 1 electron with hydrogen, and now oxygen is happy, and so is hydrogen. So what does the structure look like now? We have carbon bonded with oxygen, and then here we have all the hydrogens, and here we have the other hydrogen. There are no lone pair of electrons left on carbon, but oxygen has 2 lone pair of electrons, total of 4 electrons. So you just write it like this. Okay, and so that is now the Lewis structure for CH3OH, which is also called methanol. Okay, let's do CH2O. So again, using the philosophy that we used here for methanol, I'm going to go ahead and put my carbon first, and I know that I have these 2 hydrogens connected to carbons, So my hydrogens go with the carbon, and again I like to spread things out as symmetrical as possible, and I have one oxygen which is going to be over here. Okay, and hydrogens have to be terminal. Remember, they will never be in the middle, so you can't put them in the middle. Hydrogen has 1 electron each, carbon has 4 electrons, and oxygen has 6 electrons. All right, and then hydrogen shares 1 electron with carbon and 1 electron with carbon here. So now carbon has 2 electrons left. Carbon also has only 6 electrons total as it's in its valence shell. So that is not a happy carbon. Okay, carbon still needs 2 more electrons. Oxygen obviously is not happy because it also needs 2 more. It has 6. So both of them have 6 electrons. So they both decide to share 2 electrons between them, and that makes both of them 8. So now we represent this structure in a line structure like this. So here you have the 2 bonds with the hydrogen, and here you have this 2 electrons that are being shared with oxygen. Oxygen now has 2 lone pair of electrons, and this bond here now is called the double bond. Okay, and double bond because you're sharing 2 pairs of electrons, okay, between 2 atoms. So you have a single bond, double bond, triple bond. There's nothing like a quadruple bond. Okay, this is it. This is as far as it goes, okay, with the bonding structure. So this is how you do it. Let me go ahead and take one more example, and hopefully it will all sink in with you as to how we are doing this. Okay, so let's take CH3 NH2, and I'm going to take this one a little faster because you kind of already understand a lot of the concepts, hopefully. Okay, so hydrogen is terminal, so which means that carbon and nitrogen are going to be my central atoms. So carbon and nitrogen, central, again, spread it out, okay, as much as possible so that you can clearly see what you're writing. 3 hydrogens, 1, 2, 3 hydrogens for carbon, and on the nitrogen you have 2 hydrogens. So 2 hydrogens I write next to nitrogen. Okay, again I write the valence electrons, 1, 1, 1 for hydrogen, 1 for hydrogen here, 1 here. Carbon has 4 electrons, so 1, 2, 3, 4. Nitrogen has 5 electrons, 1, 2, 3, 4, 5, again because it's in group number 5. Hydrogen needs to share 1 electron each, so it shares that with carbon, and hydrogen here also with nitrogen needs to share 1 electron, so there it goes, it shares the 1 electron. So let's count all the electrons we have. On carbon, okay, we have 1, 2, 3, 4, 5, 6, 7. So we have 7 electrons on carbon right now, which means it needs 1 more electron. Okay, 1 electron needed. Let me just write that. And then you have nitrogen over here, which has 1, 2, 3, 4, 5, 6, 7. Okay, so here nitrogen also needs only 1 electron. Okay, so of course you know where I'm going with this. You have only 1 electron being shared between carbon and nitrogen. Okay, so now we're going to write the structure nicely and neatly. So we have carbon in the middle, and then you have the 3 hydrogens. You have the 1 bond between nitrogen and carbon, and then you have the 2 bonds coming out from nitrogen, which is the hydrogen and hydrogen, and then you have the 1 and the 2 electrons left over. So go ahead and pair them up and make it a lone pair. Okay, and this is the final Lewis structure for this compound over here. Okay, hopefully Lewis structures will become a little easier for you. This is only for covalent compounds.